tricky, right?
So will the n term will be similar like this?
You can't say like similar, exact similar, but yeah, you can expect the level kind of this, right? Thing is that you have to just clear with your concept. If you know the things, no, you will be able to do the questions and all things. You have to be focused. Like sometimes people make mistake, like in the cases at least one, at least two, at most. So they got confused. So be clear with such minor things, right?
Sir, are we going to do each and every question of mock today or just whatever we ask?
First, we'll try to do the timed questions of the timed mock. Okay. In
Yeah,
which it,
time mock only, time mocked only. I'm asking.
and if we
Practice mock or the graded one, sir?
timed, I mean, timed means that graded one. Okay?
Graded.
Graded one. Okay, yes.
So,
Is the solution available, sir?
a solution after this session we will update it on the portal, right?
Okay, both the solutions, sir.
Yes, both the solution
Okay.
we will update.
Thank you.
No worry about that. Okay, so you feel the mock was good, right?
Little bit
At
tough.
least what we studied.
Sorry.
Some was tricky, but at least what we studied, we got it right. Means at least I got it.
Okay, then nice. Yeah, some
Yes.
questions could be tricky, right?
I found
Some
week
question
11 a
were
little bit
tricky.
hard.
Good evening, sir. I could not solve this question 9 of interim mock. Other questions I could get them.
Okay, we will see. Okay, let me share my screen.
Sir, one question I have. This
Mhm.
week 11 and 12, especially the exponential distribution and continuous distribution, are these parts of stat 1 only or from stats 2?
See, thing is that these distributions, every distribution, you will study in stage 2 also.
Actually,
Okay.
what happens is there are a lot of distributions and there are a lot of things to remember. So
Yeah,
means
you
I
have to,
always
you have,
get confused with what type of
but thing is that
distribution to think.
yeah, as term, okay, as you know, as you will focus on the practice, you will things will get clear. Thing is that it took time, right? Every times people get confused when to use this distribution, when to use this distribution and all things. Yeah, but we have to do practice.
In mock also, there was one question which I thought that it was like binomial, but it turned out that it was actually a PDF type of question.
Okay,
We have to create the PDF only.
okay, no issues. Let
Can
me
you
share
also
my
tell how to approach the question?
Okay, sure. Is my screen visible to all of you?
Yes, sir.
Yes,
Okay,
sir.
so what about the first question?
Easy.
Sir, it has solved, sir. It is easy question.
Very easy.
First question was easy.
Yes, sir.
First question, right? Here
Right.
you have to ask about value of k. So you have to just apply the properties of the probability mass function. What is that?
Summation of P of
Equals
X.
to
Sum
one.
of P1,
Summation
2,
is
3.
1.
Okay, what is the first probability? I mean, what's the first property?
Positives.
Yeah, all the
Should be
probabilities
positive.
should be positive, right?
Greater than 0.
Correct. And summation of all the probabilities
One.
should be 1. And in the
One.
case of continuous integral, I mean, area under the curve should be 1, right?
One, yes.
Okay.
Yes, sir.
So I'm going to move to the second question. Which are the numerical variable?
Height and the
A
stopwatch time.
and stopwatch.
Okay.
This height
Why
and
not?
Stopwatch time.
Why not Aadhaar card number, PAN card
we
number?
can't do any mathematical
Can't do
operation on
anything
that.
on that.
Correct.
Yes, sir.
Same
These
for
are
PNR
categorical.
number, right?
Yes.
And same for PIN code number, right?
Mm-hmm.
So that means the
Okay.
rest are categorical, right?
Yeah, rest are the categorical. What about the third question?
Done, sir.
Hard nahi
No,
hua.
sir. Actually, I
No,
haven't.
sir, it was hard. This one.
This was
Okay,
easy.
it's not
This
okay.
Sir,
Not
it
we
is
have
hard.
to
not,
apply
sir.
the formula of variance for maximum value of P, that is 1 by 2,
Yeah,
right?
yeah.
Yeah, so you have to just think.
Yes,
See,
sir.
it is
That only can we got.
okay. It said variance of a binomial random variable is plotted against values of P and N kept constant, right? It is
We have to
observed that
find
the
this
maximum
N.
value of variance is 40. What is the value of N? Okay.
So it will be N into P into 1 minus P. So P will, maximum value of variance will be
Correct.
at half, right?
Mm-hmm.
So
So
half into half, 1 by 4, 1
you
by
know
4.
when variance will be maximum in case of binomial?
P is
Half.
equal to 1 by
half.
2.
When P is 1 by 2.
Suppose
Or
X,
half.
I'm saying X is and P, then variance of x is np into 1 minus p. Okay, this
Okay.
and what question is maximum value of the variance is 40. Okay, so it is asking about value of n, right? So see, you should I derive y variance is maximum for n p equal to half?
Because it is
Yes, sir. Yes, sir.
maximum
Okay, see,
value.
okay, so
Differentiate
this
and
is the
Symmetricity,
this is-
symmetricity concept.
so yeah,
Symmetricity, no?
symmetricity, by the symmetricity we can do, or we can do by mathematical.
Differentiate.
So I'm going to
Differentiate. We can directly
okay?
differentiate also.
So I will get, it will be np minus np square, right? So I will get
Yes.
n minus 2n. No, yeah, it's 2np, right?
Hmm.
So I have to put at 0, right? So it will be n equal to 2 times np, and will get cancelled out. So p will get half. Now, if you will do second derivative, so you will get it as less than 0, right? Second
Yes.
derivative, you will get minus 2, right? If you derive it in terms of p, so 2 minus 2 is less than 0. That means it's the maximum, right? So maxima at p equal to half. So it says for p equal to half, variance is 40, right?
Yes.
It is easy now, got it.
Okay, so n into half as
Is equal
40.
to 40.
So
1
n
by
will be
4. 1 by 4 is equal to 40. So n is equal
N-
to 160.
n will be 160.
Yes.
It is clear? Okay.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes. Yes.
Nice. So let's
Excuse me,
move
sir.
to the- Yes.
Sir, when can we expect the answer sheet for the practice assignment? For this,
Yeah, after the end of session, at the end of the today evening, we will upload on the portal, right?
also, if we finish this, can we solve one or two from the practice also?
Yeah, we'll do.
Okay.
Just our focus will be first on this grader. After that, we'll go for the practice. Okay.
Sure, sure.
Okay. What about question number 4?
Easy,
Done,
sir.
And
I
he
was
Just
able to-
substitute the value of xi is equal to 15.
Correct. Here you have to find the median of the new data set, and you have to apply the property, right?
Yes.
So what it will be? It will be
Ax minus b forms. So
Sir,
should
which
be-
property you are saying? I just substituted that value of xi.
see median of old data set is given to me as 15, right?
Yes.
Okay.
We are multiplying that value
Okay.
with
So
2.
I have observation yi, and my new data set is
Adding any constant.
2xi minus 2, right? And it said median for
Mhm.
this data set is. So what will be the median for new data set? It will be 2 into
2x.
15 minus
yeah.
28.
Yeah.
No need
Yeah,
to
that
arrange
I
the
did.
data in a single order, right?
Yeah, it's already.
It's clear for everyone?
We
Or
already,
any-
Yes,
it's
sir.
already clear, sir.
Yes, sir.
Okay. What about this question number 5?
Sir, I have a doubt.
Sir, I tried it.
Cleared.
but
No, sir.
I
It is
got
It is
wrong.
straight from
my side.
activity question.
I got it.
Yes,
Sir, I
sir.
did not know the,
Minus 13.5.
but on
Okay,
intuition I
that's
did
clear.
it.
Just tell me any who has doubt in this question.
Sir,
Sir, I have
doubt
doubt in this question. Means I was not
Okay.
able to get the right answer.
Okay, so let's go. We'll go one by one. I mean, each line, right? So it says an entrepreneur has invested in 4 startups, right?
Yes.
Okay. So suppose he is invested in 4 startups. Okay, let me create a new list so that will be the. Okay, suppose I'm saying let's say 4 startup. Okay, I'm going to denote I. Let's say it will take value 1 to 4. Okay. Now, if a startup makes profit, it will yield respective profits of 20, 25, 30,
25,
and 40
30 and
lakhs.
40.
Correct. This is the profit for that, right? And it says on the other hand, for each startup, entrepreneur may not gain profit. He will incur a loss of 10 units of loss. If the probability that entrepreneur will make profits from these startups are 0.1, 0.3, 0.2, and
That is
0.1.
P of X given for each value
Correct.
of the.
So for profit 20 lakh, probability is this. For 25, probability is this.
Yeah, that
For
I got
30,
it.
okay. So it is asking about expected total profit. So total profit. Okay. So now let's denote xi as the profit as the ith startup. I can make a random variable, right?
Yes.
I can say profit from ith startup, right? Means he has started 4 startup, right? Now we know loss in the negative profit. So see in the question, if you see here, it will yield 20 lakh profit and 10 lakh loss.
10 lakh
Loss.
Loss, right? And so that means probability for first
1 minus
startup
0.1.
actual is will take 20 with probability 0.1, right?
Yes.
That will
This
be
is for the profit. Now, what will be the probability when it will be in loss?
0.9.
minus 10 minus
10
10.
into 1 minus
Correct.
p.
0.9.
So what will be the
Yes,
expected for this one?
exactly.
20 into
20 into
0.1.
0.1
20 into
minus
0.1 plus
minus
plus 2.
Yeah. Minus 10
minus
into
10 into 0.9
0.9, right? That
sir, why
means
minus?
loss.
this is loss, right?
So
Oh my,
loss.
yeah, okay, got it.
See, here x1 is taking value 20 with probability 0.1 minus 10 with 0.9, right? So
Mhm.
expectation means x into px plus x into px, right? Now, what it will be? It will be 2 minus
7 minus 7.
minus 7, right? So far,
Minus
so
seven.
good. Now, come to
Yes.
the next statement. It said 25
25 again, we will do the
profit.
same, na?
Correct. Yeah.
0.5.
So
Sir,
for
I got
the
it. Sir, I got
Yeah.
it. I will do it.
so for the second startup, x1 will take 25. Its
Hmm.
probability is what is the
0.5.
0.5.
0.3, right?
Yes.
And for loss, sorry, it
Again,
will be
minus
x2.
10.
It will be
0.7
x2, right?
Hmm.
P
So
is
minus 10. So
into
see, this is
0.7.
probability for profit.
0.7.
So loss it will be 0.7, right?
0.7.
What will
0.7.
be expectation of x2?
0.5.
25 into
0.5.
0.3 plus minus 10 into 0.7, right? What will be
0.5.
minus 7.
0.5.
So 0.5.
Similarly, for the probability of x3 is I think 30 lakh, right? 30.
Yes, 30.
It's the 0.2,
0.2.
right?
And 0.2. 30 and 0.2.
So 30 is 0.2. So for loss, it is going to take minus 10. So it will be 0.8. Correct? What is the expected?
Minus 2 it is coming.
30 into 0.2 minus 10 into 0.8.
Hmm.
Correct? It will be, I think, minus 2.
Minus 2.
Correct?
Minus 2.
What about fourth startup? It will
40 into 0.1.
40 into 0.1.
So 0.1 and so it will be in loss with probability 0.9, right?
Yes.
So expected value it will be 40 into 0.1 minus 10 into 0.9.
Minus
It will be
5.
minus 5.
Minus 5.
Since first of all we have to consider the profit from expected total profit, right? That means we have to add all the things, right? Minus
Yes.
7 plus 0.5 minus 2 and minus 5. So you will get the answer, right? I think
Minus
minus
I was just
7.
not getting
13.5.
this negative part. I was not calculating this negative part.
So
That's
it
why I
will
got
be
the rand.
okay. It is clear
Got
for
it.
everyone.
Yes, sir.
Okay.
Yes, sir.
Come to the sixth question. It is asking what if a graph of binomial random variable and its 10 is exactly symmetric about x equal to 5, then what value of p will be?
Half of
Yeah,
10,
half.
0.5.
Okay, because it will be see x will be
It's symmetric now.
yeah symmetric, so half of will be left side and half probability will be for the right side. Okay.
Sir, in
I
this
just model
solution,
the
answer
graph and
one
then
is
plot.
also given as answer
Sorry.
for this question. For this question,
What? No,
accepted
0.5.
answer was
Only
0.5 and 1.
No, only
I don't know
0.5
why.
is the answer.
Only 0.5.
Only 0.5.
But yesterday I saw answer as 0.5 and 1, sir, in the
No,
result.
I
I will
think
check.
no, it's 0.5.
Okay,
Okay.
sir, thank you.
Yeah. What about question number 7?
Sir, I
got it.
please
Sir,
explain,
I
sir.
have a doubt, sir, in this
Sir, it is
question.
Yes,
standard
sir, please
uniform
explain
distribution.
this.
Can I help?
Sir, it
Okay.
is
Sir,
standard
modeling
uniform
this as random variable helped me to solve
A
this.
key will be
11 is the median value.
Yeah.
the probability of opening the lock is half.
Okay. What is the question? Question said.
So we have to find the expectation.
Yeah, that is okay. What I'm saying, robber who needs to open a lock has 21 keys, right? And it's saying out of which only one key can unlock the house. Correct?
Yes.
The chance of selecting a key is equally likely for all the key, right? And
Right.
robber will not use the key that did not open the lock in upcoming trial. Suppose I use the key, first one, and it did not open the lock, then I will not use the first
Choose
key
the first
for the
one.
another trial, right?
Yes.
Okay. So X is defined as the number of trials robber requires to open the house. Okay. So, okay, let me create a
He
page.
can open in 1 trials, 2
Okay.
trials,
So
3
X
trials.
is the
20.
number of trials okay, required to open the door
Yes.
or lock, whatever. Okay. Now, there will you can make the first case can be created like lock will be open
In one trial only.
in first trial, right?
Yes,
So what
sir.
will the probability?
1 by 21.
Correct. Second will be, suppose I'm saying lock will open in second trial. Okay.
1 by 20.
So probability x equal to 2, see number of trials. So lock will open in the second
2
trial.
by
That means he has failed in the first trial, right?
20 by
So-
21.
So for okay, so
Into
for
1 by
opening
20,
the
1
lock
by
for the
20.
success, I have 1 by 21, right? I will fail. That means 20 by 21
It's
for
by
the
20
first
by
trial.
20. Yes.
Correct.
Into 1 by
Into
20.
I'm going to pass in the second trial. I mean, lock will open in the second trial. That means 1 by
1 by
20.
20.
Correct.
Okay.
Yes,
Okay.
sir.
Because I can't use the first key for the second trial. That means I have 20 key, right? So this
Yes.
20 will get cancelled out. Again, I will have 21. Correct?
Yeah.
Sir,
Now-
hello, sir.
yes.
Hello, sir. Sir, I didn't get it. How have you actually done this one?
Okay, see what in the question said. In the question, it said the robber will not use the key that did not open the lock in the upcoming trial, right?
Yes,
Now,
sir.
if you come to the question, I'm
Without
saying
replacement.
lock will open in that second trial. That means lock
It
will
failed.
not open in the first trial.
Yeah.
Correct. So
Hmm.
for opening the lock, I have probability of 1 by 21.
Cannot
If lock
open
will
it,
not
but
open the
minus
cross,
21.
so for not opening the lock, I have probability of 20 by 21. Correct.
1 minus 1
Now,
upon 21.
see, in the first trial, I failed.
Hmm.
But now I have used the one key, right? That means I have remaining 20 key.
Yes,
Okay.
sir.
So for the opening the lock in the second trial, I have probability of 1 by 20. Okay. So similarly for the third trial, that means probability that fail in the first trial, okay, and fail in the
second trial.
second trial, and
Success in the third trial.
pass. I'm right as pass in third trial. You can interpret as lock is open in the third trial. Okay.
Success.
So it will be for when lock will not open in the first trial. 20 by 21.
21.
Now I have 20 key now, right?
19.
Yeah.
So what will the probability for not
19
opening
by
the lock?
19 by 20.
Correct.
19.
19 by 20. Now what is the probability for lock will open in the third trial?
18,
1 by 19.
1 by 90.
1 by 90.
1 by
Correct.
19.
So this will get cancelled out. Again, I will have 1 by 21.
1 by 21. For everyone,
Similarly, you
it
will
will be
get
1 by 20.
yeah, for x equal to 4, x equal to 5, you will get same
Sir,
probability.
sir,
Right?
sir, 1 second, sir. Sir, P x equal to 2, we got the probability of 1 is 1 by 21. So that is for opening.
Yeah.
Not opening means again it should be 20 by 21, no, sir. Or at least 19 by 20.
I approached it
No.
in a different way.
See. Suppose this is for the first trial, right? X equal to 3 means 3 trial. Okay. This is the different case. X equal to 3
No,
means
I am talking third trial. If x equal to 3 means it should not be opening in the first trial. It should not be opening in the second trial. The
correct.
third trial only it opening.
Okay. What is the probability lock will not open the first trial?
First trial, okay, sir. Not opening 2021 because 1 by 21 we are subtracting 1 minus 1 by 21.
Okay.
So second trial, the probability of opening the second trial we got is 1 by 21.
Sir,
1 by 21 is the probability. No, sir.
Okay. Listen to me.
So that should be 18 by 21, correct?
I approached it in a
Oh,
different
no. Correct. You are correct.
See. Listen to me. At the first trial, I have used one key, right?
Yes, sir.
I have remaining 20 key.
Okay, sir.
What will be the probability if out of these 20 key I can open the lock 1 by 20?
1 by 20.
What will be the probability if lock will not open 19 by 20?
Okay, 19 by 20.
That's I have written here.
Yeah, that's correct, sir. 19 by 20 is not opening.
Correct. I see. Lock
And
will not
what
open
is
in
the
the first.
between,
Lock did not.
what is the difference This P of 2 equal to 1 by 21 and 1 by 20. What is the difference, sir? Actually, 1 by 20
See,
and
here
1 by
you are getting the value same.
Sir,
Okay, that is the not
sir.
funda. I'm trying to explain the concept here. What's the how you are going to get the same value, right? It's not like that.
Naren, P of 2 is the outcome. Okay. And the opening in the second try
Yeah,
is an event. Okay. The probability of event is 19 by 20 or 1 by
you are going to
20.
compare this outcome with this outcome, right?
Yeah.
That is the not thing.
Sir,
Yeah.
I have a question here.
Yes, yes.
In question, it says that only one lock can open the.
One key
Right.
can open the lock.
Yeah,
So
Sir,
every time only one will be there. So
Sir,
it will be
sir.
always be 1 by 21. I use this logic.
no,
yeah,
sir.
that's
See, according to me, the lock has two possibilities. The
okay.
key can either open it or it cannot open it. So the probability of each key is only half to open.
Okay.
So there are 21 keys,
Mhm.
and that is n is equal to 21. And we multiply by the probability half.
Mhm.
Then we'll get 10.5. But because 10.5 is not a full number, you have to try at least 11 times.
Yes.
Okay.
So that is
No,
how I
that's
approach
not,
this.
that's not a fair argument.
approach.
Out of the 21 keys,
Instead of
one
doing
key
it
has.
by 1 by 21 method.
No, see.
No. Out of the 21 keys, one key has 100% probability. All other
Correct.
keys have zero probability.
See.
All other
Listen
keys
to
have
me.
No,
zero
every
probability.
key
It's not.
has the probability of either
Rohini.
opening
No,
or
it's
not
not
opening.
correct. Na. Only
Rohini,
one key
listen
can
to me,
open.
listen to
All
me.
other key cannot open.
Each key can either open or not open.
Okay,
No,
Rohini,
that's not correct, no.
listen to me.
Calm down.
See, listen to me. What I'm saying. See, Rohini, you are going to do, you are considering your success probability same for each trial. You are saying
Each
1 by
key
2,
has the
1 by
same
2.
probability of half.
Sorry?
Whether it can open or it cannot open.
Okay.
So now because there are 21 keys, we multiply that 21 by half. We get 10.5.
So it will
But
not be equally
because
like this.
the number of tries cannot
No.
be
So
half.
how
We have to
you are
go to
going
the
to consider
next
as
higher number.
no. You are
And
taking
that's
as
how we get 11.
see. If you are going to take half, that means you are considering the probability as equally likely, right?
Yes, sir. It is biased case, no, sir.
But it's not like that. Thing is that, see, okay, I have 21 key, right? Let's consider for 5 key. Suppose I have this 5 key, right?
Okay.
What I'm going to say, I'm saying out of this 5 key, only one key will open the lock, right?
Yes.
And condition is that suppose I will not use the key again, I mean in the upcoming trial, which I have used for earlier, right? So it's a simple thing. So for the first key, suppose what is the probability first key will open the lock?
1 by 5.
1 by 5, right? Out of those 5 key,
no, sir, the probability of a key opening or not opening is only half.
Okay,
either it will open.
You don't have one key. You don't have one key. You have 21 keys.
Any one key will open, but any key, whether it will.
No, your logic will fit only if you have only one key. But here we have 21 keys.
No, in spite of having.
So Rohini, I will ask you one question.
We can deal it that way.
First key also having a possibility of opening the lock. Second key also you have the possibility of opening the lock. So each key, you cannot label that all the 20 keys are not going to open and only the 21st is going to open. So for a key to open a lock, whether it can open it or not opening, not open it, that is the probability.
Okay, what about I'm not suppose I will not use the first key or second key, any other key.
Any key which will what according to me is each key has a probability of opening or not opening.
Okay.
You can have the first key also to open or the 20th key also to open or 15th key also to open. So each key will have a probability of whether it will open it or not open it. So any key will have only two possibilities, whether it will open it or whether it will not open it. So that is how I got probability as half.
I will give one
I have a
example.
question.
No,
Sir,
I
sir,
have a
I will
question.
give one
If
example.
only
Sir,
one
sir,
key can
For
open,
one
now,
second.
suppose
any other key
Sir,
can
one
open.
second.
Yeah, see, listen to me. If you want to discuss the question, so please ask and discuss one by one. Okay. If you will make yours, we will end the session. Okay. So please, I mean, this is the mock discussion. That's okay. But thing is that ask and discuss one by one. Okay. That's a request from outside. Okay. Yeah, please. Naren, what you want to say? If you will make yours, so no one will, okay. No one will get their doubts clear.
Sir, yes, sir.
Okay.
Thank you,
Yeah.
sir.
Yeah. So
Sir,
please go one by one. Okay. We'll discuss the things. We are here
I
for
would like,
discussing things.
I would like to put up an example. Why we are thinking it is 1/2 is basically we are thinking about a coin which is having head and tail, which is equally likely.
Correct.
I am putting a question there. If a coin I am giving you, both sides are head. Okay, like that, 5 coins. And in one coin, I am giving both sides tail. Now, madam, you tell me, one coin, if I put the both are head, if I throw, what is the probability you will get a tail? Both sides of the coin is head. What is the probability you will get a tail? As per this coin, two sides, I have to get 50% tail, no? Correct or wrong?
Yeah, see, thing is that for every...
then it is not a fair coin.
So can I say something?
Madam, it will not open. One key will not open at all. Only one key will open. All other keys will not open. It's zero possibility.
So can I once say something?
Yeah, please go ahead. That's it.
So here it is 21 key. If we generalize for n key, we get expected value equal to n plus 1 by 2. For 22 key, it's 23 by 2. So you see, if from her logic, for 22 keys should be 11. But from our logic, it should be 22. It's 22, 23 by 2. That's equal to 11.5. So that it works in here, but it won't work in other cases.
Sir, simply it is uniformly distributed, no, sir.
Yeah, that's okay. Yeah, that's okay. That's you can proceed like that also. In uniform case also.
Uniformly distributed. That's it.
Correct. That was the correct approach. So what about Rohini is saying? See, she got confused. That's okay. She has also another approach. That's okay. So Rohini thing is that it's about, see, suppose I have dice. Okay. Right.
Yes.
Okay. Forget about dice. Let's take toss of coin. So it has only two possibility, right?
Yes, it has only two possibilities.
Right. And I know, suppose it's an unbiased die or fair coin, so it will be half and half.
Yes, that is what I was thinking, that the key, either it can open or it cannot open. So it is half.
Okay. So tell me about, suppose I'm going to roll 2 die. Or suppose I roll a die,
dice has 6 sides.
I mean, sorry. I want to say
coin will have 2 sides.
Yeah, suppose I have coin, right? Suppose I toss the coin 3 times, right? For every time, what is the probability of getting hit? Half?
Each time it is half.
Right?
Yes.
Now, come to this. Suppose for every time, for every trial, right? Is it same probability?
Probability will be same, no, for a key, any key, because we don't know which key will open. So we assume that the probability of any key to open will be either it will open or it will not open.
So, so according to you,
there are only 2 possibilities for each coin.
Okay, listen to me. According to you, it should be 5 by 2. Okay, for this particular example, right?
Sir, can I, sir?
It should be 2.5. Yeah, please go ahead.
Sir, ma'am, we have to take all the events, I mean, say the keys all together. Like 5 keys are there, suppose 10 keys are there. So what are the probabilities for each keys to open that lock? Not individually we have to look at.
Yeah,
like
it is
if we have
of
tried the first one, if it is not open, so it will suppose 5 keys are there. So the first keys has a probability 1 by 5 among the all 5s. So next trial, if we fail in the first trial, so remaining 4 are there. So possibilities to open any of the keys or lock up with any of the keys is 1/4 there. We have to look at in the whole, not individually.
It is asking about Rohini, out of 21 keys, I know only one key can open the door. Yeah, lock.
But the property of a key is either to open or not to open.
Sir, 1 second, I can give one more example, sir.
Okay, please go ahead, Naren.
Sir, here the question says only one key will open. For argument's sake, I will say 8 keys can open out of 21. Madam, how we will solve this problem? 8 keys can open. There are
Suppose I'm
keys,
saying
all 50, 50, 50%.
Yeah, you can take another number. 3 keys can open the lock.
Open.
Okay, Rohini?
Basically, this is not uniformly distributed.
But then the expectation will be increased by 3 times.
Okay, so then you are going to multiply 15. Okay, just try to think, Rohini, okay? I'm not saying you are absolutely wrong, but try to think, okay? What, okay, so according to you, for 5 key, you will get 3. For 6 key, you will again going to get 3, right?
Yes.
Okay, so just try to think for this.
Sir, can I make a comment, please?
Sir? Yeah, you can, please go ahead. That will be fine for us.
Okay, so if we apply the coin logic, which is what you're applying to keys, then imagine we had only one key, and that key doesn't, you're saying that key has the possibility of opening the lock or not opening the lock.
Correct.
But the reality is that key, if it cannot open the lock, its possibility is 0, not half, because the key is not a coin.
That's how, see what, that's why I'm trying to explain to Rohini. Rohini, for the coin, you have two, two faces, you can say, right?
Yes.
2 faces for, and for outcome for either head or tail, it's same. Okay. But in the case of lock, right? So you are getting, I think you are getting confused, like for half and half. Okay. Okay. Just try to think about this example and this example, and then it will be 3 or 4 keys. Okay.
So we'll go next,
Sir, can I try one last time? Because it's fair. Sir, you make a tree diagram. Just make a box.
Okay.
Okay, and then take out 2. Partition it. No, make just small because we have to make it many, right?
Yeah, let's take a 4 key.
No, I'm saying tree diagram. Tree diagram.
Oh, okay. You are saying tree diagram.
Yes.
Okay.
So like we have 21 keys at first, and then you take out 2 arrows. One is pass and one is fail.
Okay.
So upper one is pass.
That means it will open.
Yes.
Okay.
And the lower one is fail. Okay. So if it is pass, then it is out of 21, only one key will be there, because we have 21 keys and only one key can open that door, like whatever it is. Yeah.
The answer will be 1 as per you.
Yeah, that's
as per me.
Okay.
I also did the same thing, madam. So I got the answer as 1.
No, it won't come 1.
See,
and
that's the same thing we had done here, right?
Yes, sir. This is the same thing which you have done. Yeah.
Which is same, we can say.
And from the lower one, you have to again bisect into 2, not the upper one, the lower one.
So yeah,
no.
That's
not from the.
See, from here. Okay, that's okay. That's
the
fine.
upper one will be not, sir. Upper one just remove the arrows. No, because it won't. We don't need it because right.
Yeah, right. Sorry about
that. For the lower one, we will bisect again, pass and fail.
Correct. Because for, see, as you can see here, for the first trial, suppose the lock is open, right? So for this, I have probability 1/21. Suppose at the first trial, lock is not open, right? That means at the second trial, either it will open, right? So what is the probability at the second trial? It will open 1/20. Correct. Now, what is the probability it will not open? 19/20. Correct. Yes. So from where it can open? Sorry, for opening the key, it's 1/19. For not opening, 18/19. Right. Similarly, you can do right the same thing which we have done here, right? Sorry about this.
Sir, one question. So this part I understand. For each try, x equal to 1 is 1/21, x equal to 2 is 1/21. That part I understand. But how do we calculate the expectation for this? I mean, that is what I don't understand. Is it 1/21 to the power 21?
No, it is sum of
1
to
it will be sum
21.
of the right,
XPX,
because for see what your x is. X was the number of trials to open the door, right? I mean to open the lock, correct? Okay, x was the number of trials to open the lock. So what will be the expectation of x? That means I have to consider the expected for each trial, right? So it will
1
be
into 1 by 21, 2 into
Sum
1 by
of
21.
correct,
Like,
correct. 1 into
okay,
1 by
okay.
22, sorry, 21 plus 2 into 1 by 21 and so on.
up to
21
21.
times 1 by 21. So 1 by 21 will be outside. So it will be 1 plus 2 plus so on plus 21. So
All are
21 into 22
Into 22 divided by 2.
divided by 2. So you will get 11 directly. Okay.
Hmm.
For Rohini, just try to think about that half. Okay. I will also look into it. Okay, and we'll
Okay, thank
get
you,
back
sir.
to you. Okay, and you can post on the discussion discourse. We'll look into that. Okay, no issue.
Thank you, sir.
Okay, this approach is clear so far, right?
Yes, sir. Yes, sir.
I
Thank you,
understood
sir.
it.
Thank you.
Okay.
I understood this also.
Okay, no issues.
Hello, sir. Hello, sir.
Yeah?
Excuse me.
Yes.
Sir, could we approach it to by another method that by using direct expectation formula that was told by the professor in the lecture?
Which one?
Expectation of uniform distribution random variable.
Yeah, that's the same thing, right? See, okay.
Yeah,
Suppose,
exactly.
Yeah, you can put the value of n, or either you can do
Yeah,
manually
because
that.
sir,
Yeah.
initially it is a uniform. Initially before applying anything, it is uniform. So directly we can apply n plus 1 by 2 and get the expectation without doing so much lengthy process. Yeah, is it approach a good or?
See, it's not kind of lengthy. See, if you remember the formula, right, you will directly apply the expected. Suppose you don't know formula, right, then you can do by manually,
then we need to proceed all these things. Okay.
Okay, so from now onwards, I think this answer will continue. Okay, I have to go for some work. So I have completed till question number 7. You can proceed with the question number 8.
Okay, yeah, sure, Prashant.
Yeah,
Thank you.
yeah, thanks. Yeah.
Okay, let me share my screen.
So the question 9, I would like to see how it has been solved.
Yeah, we will come to
8
that.
also.
Yeah.
8 also.
But we are doing the question 8 also.
Okay, so first 7 questions, I think Prashant has covered the first 7, right? Okay, great. Okay, so moving to question number 8. Okay, so were you able to understand the question statement? Like, how did you approach this one? Any one of you?
Sir, we took actually
ensure the 3 places where John
first
has
and
parked on
last
both
place.
sided are already.
Okay.
See, according to me, he has 2 empty slots on both the sides.
So we have to make a box.
So total,
We don't make as one.
We have
Or
to
3
make
sides as a one.
And
11
then
boxes if we make, leave out the 3 boxes.
Okay, so what the question is trying to say is there were 11 parking spots in a mall, right? 3, 6, 7, 8, 9, 10, and 11, right? There were in total 11 parking spots, right? So John has parked his car, but he has not parked on the end spots, right? So he has parked among any of these 9 spots, right? So
Yes.
let's suppose he has parked it here. Okay, so now he went for shopping and he came back, right? So after he came back, how many ways it is possible that there are exactly 5 cars?
9C5, sir.
Including his, right?
Yes.
So initially in the question, it was mentioned that if you read the statement that he has parked his car among 10 other cars, it means the parking slot was completely full, right? All those 11 slots were full. He parked his car in the only empty spot, right? So after that he came, but our condition is that okay, our condition is these 2 spots should be empty, right?
Yes, sir.
Empty. His car will be the fixed, right? His car is already fixed. It's not moved anywhere. He parked and went on shopping and came back, right? So of the remaining 8 slots, 4 slot, these 4 slot, right? Of the remaining 8 slots, there should be 4 more cars, right? Only then there will be total of 5 cars, including his car when he came back after the shopping.
Yes, sir.
Yes, sir. Right. So in how many ways would that be possible?
8C4.
8C4, right? 8C4, I think it's close to something 70 if I'm not wrong. Right?
Sir, can I ask you in this?
Yeah, sure.
Sir, it was objective question. That's why my answer was correct, because I couldn't proceed. I couldn't get my perfect answer. But what I was thinking, like, why we are fixing the car, like at one place? It could be possible that he might have parked his car somewhere else. Like, why we are not considering that?
Okay, so if you read the first line, John parked his car among 10 cars, right?
Yeah.
Among 10 cars means there were already 10 cars parked.
So we have, in that case, we have to consider that there is only one place.
Yeah, there is only one place. So him parking in that spot is there is only one way that he can park it over there, right? There is only one space left.
Okay, if it is not mentioned that like the cars are already parked, then we have to consider all the cases.
Yeah. Can you explain it again, please? Basically,
Correct.
that C4 part.
Sir, let me, sir, please finish this first. So that means if it is not mentioned, like the 10 cars are already parked, then we have to consider all the cases, right?
Yeah, then you have to consider the cases where his car could have been parked, right? But now it is given that there is only one space, so that's only one way he would park.
So, sir, he parked his car 11th position. Then there will be no
any of the remaining
empty
position,
spaces
yeah.
both. Then there will be no empty spaces both side of this of that car, right, sir?
It is written
Not
that
at the
it is not
either end.
parked at the end.
It is clearly mentioned. It's not at the
either end.
So it means that it would be in between some
second
acting
and
slots.
10th place.
Okay.
It can be from 2nd to 10th place only.
Sir, why we are taking it as 8C4?
8C4 means
Because places are to be left out because 2 places are empty on both the sides.
Okay.
And his own parked place.
In total, there were 11 slots,
Out of
right?
11, yes, 3 places are out.
One slot is occupied by John's car, right? After that, 2 beside his, like this slot and this slot, these 2 are empty, right?
So total 3 you have to leave out.
So now you have in total 8 slots left,
8
right?
slots are left.
Why 3? Because it is one is his car.
One is
right?
on car and 2 empty besides, right? So of this remaining 8 slots, there should be 4 more cars, right?
4
then
more cars,
only there
because
would be
one of the cars is his.
okay. Only then there would be 5 cars in total in the complete row, right? Including his car. So we need to select which 4 places would be occupied of the remaining 8, so that you can do in 8C4 ways, right?
Excuse me, sir.
Yeah.
Does the order of other 4 cars doesn't matter?
No, order doesn't matter, right? This could be any 4 cars at any 4 spots. We just need exactly 5 cars to be there. We are not interested in which car is occupying which spot, right?
So I didn't get the 9th one.
Hello, sir.
Yeah.
If the car is not at the 6th place, if is it at the 5th or 4th, any other in the state of the end, then it is the
then
same
also
answer.
it would be the same. Yeah, then also it would be the same answer.
Okay, thank you.
Okay. I've just selected that spot at random, so it could be any, right? Any of the remaining one.
Oh, okay. Thank you so much.
Okay. And is it clear? Question number 8, everyone?
Yes, sir.
Sir, you can choose any other spot, but except the end slots, is it?
Yeah, he has only one option because it is clearly mentioned there are already 10 cars parked in there.
Yes.
So he would be left with only one option.
Okay.
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 Okay. Moving for the question number 9.
Yes, question number 9, I couldn't solve.
Okay, how did you approach it? Any one of you?
I found out the possible ways of Nina getting a sum of 7. That comes that comes out to be 6 out of 36.
Okay.
And for Sam, it will be sum of
7.
so the number of possibilities is 5 by 36.
No, that is also 6 by 36 only.
No, it can't be 6 by 36 because
Yeah, that's 5 by
open
36.
is 6, no? Sum is 6. So when you are throwing 2 dice, then the total will always be more than 6.
5 by 30.
Sir, explain in detail,
please.
Yeah, okay. So
Sir, please also cover if this not an infinite series, how will we solve? Okay, infinite series, I think we can solve in one method. If it is not, if they say given is a maximum number of say 20 times, 20 tries, then how do we solve? Okay.
Then how do we solve? Okay, then there would be multiple cases. It is possible that nobody would have won, right?
Yes. So
That
I
case
just
is
want to
also
know if
covered.
that is also need to be covered.
Okay, that we can do. In that case, you will use, I think, sum of finite GPs instead of infinite GP. That won't be much trouble. Okay, so Nina, okay, let us define two events, right? N is Nina winning in any of the round and S being Sam winning in any of the round. So Nina wins the game when she gets the sum of 7, right? So sum of 7 you can get, like, what are the chances of getting a sum of 7 in a roll of 2 die? 5.
6 by 36.
6 by 36.
6 by 36.
6 by
Okay,
36.
what about getting a sum of 6?
5 by 36.
5 by
36.
5 by 36, right? Okay. Now, who is beginning the game? Nina.
Nina has to win and she will start first.
Okay, so Nina wins the game we have to find, right? Okay, great. So Nina wins the game. Okay, so what are the possible cases?
Nina wins the first game. Nina wins.
Oh, yeah,
does
Nina
not
wins
win
the first game, right?
Plus, Nina does not win the first game. Nina wins the second game.
And then, yeah, Nina loses first round, right?
Yes.
Then
Sam loses first round.
Sam also has to lose, right?
Yes.
Yes, sir.
Then Nina has to win, right?
Yes, sir.
Another way is Nina loses, then Sam loses.
Didn't got this. Nina has to
Nina
lose
again
and then Sam has to.
Nina
Okay,
loses, Sam loses.
so you have to find the chance, like Nina wins the game, right? So it is possible that if Nina is starting the game, she wins in the first round.
Yes, sir.
If she didn't win in the first round, then it's Sam's turn, right? So Sam also has to lose, and then there is a chance that she wins.
Why
in the
Sam will
third round.
lose? Why Sam?
Because we are finding the cases where Nina wins. That's why Sam has to lose.
Okay.
Similarly, another way is Nina loses the first round, then Sam loses, then again Nina loses second round, then again Sam loses, and then Nina wins. This is
Then
also
Nina wins.
possibility, right?
Yes, sir.
And it can
And
go
so
on up to infinite, right?
So why it is going till infinity?
Because it is possible that even after 1,000 rounds, like Nina loses 1,000 rounds, Sam loses 1,000 round, and then they win in that 2001 round, right? It can keep on going. None of them could win. That's also a possibility. It can go on a long run.
It is an infinite series then.
Infinite series, yeah. Okay.
Yeah,
so
but expected 6 will be there, no, sir? Nina winning, there should be some expected number.
Expected number, yeah, you can compute that also, right? That's the probability of, you can have to find that she wins in the first round and she wins in the second round. You can find out the expected number of rounds in which she will win. That's also a possibility you can compute. Okay, now let's stick to the question part for now. Okay, I think yeah. So if you notice carefully, these events are disjoint, right? These all are disjoint events, right?
Yes.
Yes, sir.
So if they're disjoint, then I can write A union B as probability of A plus probability of B, right?
Yes, sir.
Yes, sir.
Would be probability of Nina winning plus probability of Nina losing, then Sam losing, then Nina winning, plus so on, right? Right. Okay. And one more thing which is given in the question is
Independence.
each round is an independent, right? The result of first round would not affect the result of second round, right? So if two events A and B are intersection, I can write them as individual products, right?
Yes, sir.
So it would be probability of n, and these all are independent, so I can write it as
n complement s complement,
right? Let me just write it down, this one too. And plus so on, right?
Yes, okay.
Okay, now recall what is probability of n Nina winning. It's 6 by 36, right? Then n complement, it would be 1 minus 6 by 36, right? Just 30 by
30 by 36.
30 by 36.
Then s complement would be 31 by 36.
31 by 36.
Then it would be again 6 by 36, right?
Hmm.
For the next, it would be n complement would be 30 by 36, right? It is multiplied 2 times. Then s complement is also multiplied 2 times, right?
Hmm.
Square, then 6 by 36, right?
Okay.
Similarly, it will go on, right? It will become cube, then raised to the power 4, and then raised to the 5, and go on. Right? So if you notice carefully, it is
geometric progressions.
By 36 common, yeah. It's 30 by 36 times 31 by 36. Right? It is geometric progression. The sequence inside the bracket is geometric progression, right? With the first term being 1 and common ratio being 30 by 36 into 31 by 36, right?
36. So
Is
geometric
it clear?
progression.
Yes, sir.
Okay, great. So as you know that the sum of infinite GP is nothing but A over 1 minus R, where A is the first term and R is the common ratio. So it would be A is first term over 1 minus our common ratio. And now you can solve this expression to obtain the probability.
Yes, sir.
Okay.
Similarly, if you have to find for Sam winning, either you can do 1 minus Nina winning, or you can make the sequence for Sam winning. Right?
Sir, can you explain the last step again? The formula. This A.
This one?
No,
Okay.
about the formula.
The formula. Okay. So sum of infinite GP is first term of the sequence divided by 1 minus common ratio. Okay. So here, if you notice, your first term is 1, right? This is your A. And common ratio is, if you do second term by first term, if you divide second term by the first term, you will get this, right? Similarly, if you divide third term by the second term, you will again get this thing, same number, right? So that's the common ratio. That each next term is multiplied by this same constant number. First term multiplied by this constant, we get this. Now this term getting multiplied by this constant, again we get this term. The next term would be multiplied again by this constant, it would be cubed, then raised to the power 4, and then so on. Right? Okay. So you can directly use the formula to find out the sum of this sequence, which is A over 1 minus R. Is it clear now?
Yes, sir.
Any doubt?
Yes, sir.
Yes, sir, got it.
Okay, moving further, question number 10.
Sir, I was asking one question here
Yeah.
about if there is a limit given on the number of trials, then how do we get expectation or probability?
Okay, if there are limit given, okay, I will just give you a brief idea on it. Okay, let's keep the number small for now. Let's say there are 10 trials maximum, right?
Yeah, that's fine.
Okay. So what would happen is if Nina is starting the game, right? There are multiple cases. Okay, so first we want to find out Nina winning the game, right?
Yes, sir. I want to use the same example. Nina starts, Nina winning the game.
Nina started,
Find the
Nina wins.
probability for 10 trials. Yeah.
10 trials. Okay, if I have to write it down, let's make it 5 so I can write it down now. Okay, so what would happen is suppose Nina starts first, right? So Nina wins. Then Nina loses, Sam loses, and then Nina wins, right? Or it can go on like that. Sam loses, Nina loses, Sam loses, and then Nina wins, right? So that would be
Okay,
your
so we need to
5 trials.
find out for all the 5 trials, up to 5 trials. Is it?
Yeah, in that case, it won't be infinite GP, it would be finite GP only.
Okay.
And then you need
Sir,
to use the
Okay, so
formula.
this I understand. I can work it out. Okay, so we just need to put it as power 2, power 3, power 4, power 5, and then find the value.
Yeah, that
So
is
power
the
10 it will
formula
be.
for finite GP, right?
Okay, okay, sir. Okay, got
Sir,
it.
n will be 10 here, no?
No, for 5 trials, 5. For 10
Okay.
trials,
N
10.
would be 5. And it will, I think it would be 5, right? Yeah, it would be 5.
Okay, sir.
You
Okay,
will have
thank you.
5 terms in sequence. Okay. N is number of terms in the sequence. Okay, moving further. Question number 10. I think it's pretty easy. All of you might have done it. Is there any doubt in this?
No, sir, I didn't do it.
Clear, sir. Sir, move ahead.
Sir, what is this f of 1?
F of 1 is CDF, cumulative distribution function at value 1. It means
I was not
probability
getting this f of
Less
1
than
part.
equal to 1.
F of 1 is a
1 means
notation
P
for
of X less than equal to 1.
Less than equals to 1, yes.
is a notation for CDF, right?
Then it will be 0.
Okay. So what about question number 11?
This I didn't understand.
11 expensive.
What this bar is
Because-
is that a conditional probability?
Conditional. Yes. That's what the notation for conditional, right?
Yes, sir.
Property, no, sir.
Sir,
Yeah.
for the finite one in the above question, you said some formula. What was that formula?
That formula won't be used, but yeah, if you want, you can check this. You can also
1 minus
figure
r
it
to
out.
the power n by 1.
Okay, so question number 11, any doubt or were you guys able
Yes,
to do
sir,
it?
please
Can you
explain.
solve question 11?
Sir, please explain.
Okay.
And a little half we have done, but then somehow didn't get 11, please.
Okay. I will switch to this board. 1 minute here. Okay, so for question number 11, you know that your random variable follows exponential, right? Parameter lambda. Okay, and you need to find out this, right? This is the question, right?
Yes, sir.
Okay.
Correct.
So if you look at this, so you recall the formula for conditional probability. What is the formula of probability A given B?
A into B by
intersection
B.
B upon A.
A intersection B by B.
P.
Right. So here your A is that your X is
Greater
greater
than
than 100 and B is that X is greater than 50. So what is A intersection B? If you plot it over here, let's say this is 50.
Greater than 100.
This is 100.
50.
Right. So your event A is this complete area, right? And event B is this complete area. So what is intersection? Intersection is all this
50.
area, right?
Okay.
So A intersection B is
Yeah.
all the region of X which is greater than 100, right? Okay. So we get probability X greater than 100 divided by our B is this, right? 50. Okay. So I can write it in terms of CDF, right?
For how?
But okay, so probability x greater than 100, it is same as 1 minus probability x less than equal to 100.
Yes.
And this is what? This is nothing but CDF, right?
Okay.
So what is the CDF of exponential distribution?
E to the
E
power
power minus lambda.
x.
Lambda x, yes. E to the
CDF.
power minus ex to the power minus lambda x.
Okay,
1
go
minus
and go through the lecture videos again.
1 minus e to the power minus lambda
Yeah,
into
1
x.
minus. Yeah. Minus
E to the power
lambda.
minus lambda x.
And denominator it would be. Okay, we'll just mute background. Yes, yeah. Clear, right? Clear till this step?
Yes, sir. Yes, sir. We got, sir.
Okay, so in the next step, it would be 1 gets cancelled out, right? So in numerator, it would be minus 100 lambda, and denominator it would be minus 50 lambda only, right?
Yes.
So if you do it, it would be e raised to minus 50 lambda, right?
Yeah.
Yes, sir.
50 lambda, right? So e raised to 50 minus this is probability of x greater than z, right? That's what given in the question. Probability of x greater than z is same as probability of this conditional probability, right?
Yeah.
So okay. So probability of x greater than z we know is e raised to minus 50 lambda, right? It means 1 minus f of z is also equal to this, right? Is this step clear?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, so it means our f of z is nothing but 1 minus e raised to minus 50 lambda, right?
Yes.
So from here, you can tell that z is equals to 50, right?
Yes, sir.
So that's your answer.
Yes,
I
sir.
have a doubt.
Yeah.
Sir, in the question, it is given that x is greater than 50. If we take x is less than 50, then how will we solve it?
You have to proceed in the similar manner, right? In that case, your intersection part would be 0, I think.
Yes, sir.
Yeah, so,
Just can you scroll up?
okay. Yeah.
So I didn't get that union step. This P union, P probability of A union B.
A intersection B.
Sorry, intersection.
Okay, so your A is that x takes the value greater than 100, right? And B is that x takes the value greater than 50, right?
Yes.
So A intersection B would be the common region. So what is the common region between the two events?
Between 50 and 100.
Between 50 and 100, but B, A is greater than 100. A don't even have any area in between 50 and 100.
Yeah.
It is all the area greater than 100 would be the common region only, right?
Yes, yes.
That's why it's A intersection B is x greater than 100 only. Okay, so one interesting fun fact about exponential distribution is if your x follows exponential, right, with any parameter lambda, then probability of x greater than a plus b given x is greater than, let's say, b.
Memoryless property, sir.
Yeah, it is always same as this. So in this question, if you notice, your x is greater than 50 plus 50, right? 100, and your b was 50, right? And you find out that your z comes out to be 50. Right? So,
Sir, can you solve question number 10, please?
Okay, thank you, sir.
okay, is it clear, everyone? Question number 11.
Yes, sir.
Okay, great. Okay, moving further. Okay, question number 12. Were you able to do it?
Sir, can you solve question number 10?
Question number 10. Okay, how did you approach this one?
Sir, couldn't actually start only.
You can just try on yourself first. Okay, just go through the lecture video and solve it. It's the, I think, easiest question of this entire.
Okay, sir.
Okay, question number 12. Anyone?
Yes, sir. I have a doubt.
Okay, how did you approach this one?
Sir, I have approached with the it's a uniform distribution probability. But actually, I did a mistake. I think in the place of the second, actually I did with the minute. So, and then I didn't get answer. It's maybe a mistakes, but sir,
I'm not
also a
getting
little bit confusion, sir.
It's a uniform distribution, right?
Yeah.
Uniform continuous distribution.
Yeah, continuous uniform.
Continuous, yes.
Plus conditional probability.
We should calculate the CDF at 4.
Okay, so what the question is saying is, it is saying that according to a survey, a time taken by teenagers to finish a box is distributed uniformly, right? It could be any time between 1 to 6 minutes, right? And then later on, you notice that the unit of time is changed to seconds. So it's easier to bring it all into one single unit. So let's convert this minutes into seconds, right? We can easily do. That would be 60 to 360 seconds. Right?
Yes.
So let me just write it down. Okay, so our random variable x is now uniformly distributed between 60 to 360, right?
Okay.
Okay. Next, the question statement saying that the one who finishes, okay, whenever who finishes it in 100 seconds wins the grand prize, right? Okay, so let me define some event. Okay, let's say this is G for grand prize if our x is less than 100, right?
Okay.
Then a teenager accepted the cafe challenge. Okay, so what is the probability that he will finish the box in 240 seconds, right? 4 minutes is 240 seconds, given that he lost the challenge. Okay.
Sir, what is the point of that given that he lost the challenge? Because if he completes it in 4 minutes, then already he lost the challenge. So what's the point?
Given that he lost the challenge means he has already crossed the 100-second timer. Now you are asking for probability that he will finish it in 240 seconds.
Okay, got it.
Okay. So it means you need to find that he will finish it within 4 minutes, given that time taken by him is already greater than 100. Right? That's again simple conditional probability you can solve, right? Okay, so what would be the intersection of the above part? X less than 2.
240 to
Sir,
100.
can we do the same fun fact which you have taken?
Which one?
Means in the previous example,
It was for
P of x
exponential.
greater than a plus exponential. Yes, sorry.
That only for exponential, not
Yes,
for
yes,
uniform
sorry.
or
Yes,
integration. Okay, great. So now you can, I think, plug in the values for CDF of uniform and then evaluate, right? That would be f of 240 minus f of 100.
We have to calculate that and then we will plug in.
Yeah, just plug in the values of this CDF and you will obtain the final answer, right?
But means that for that we need the probability for each individual values.
CDF, right? You need to find out the CDF.
So
you know the
just
formula for
integration
CDF.
we have to do, na? Integration we have to do.
The integration, if you're aware of, or I think for uniform, you have the direct formula also, right?
X minus A by B by A.
X minus A by B also is there.
Right. Yeah. And X is within the range of A to B.
62? No.
So 240 would be 240 minus our A is over here 60 and
60.
B is 360 minus 60. Similarly, you can find out f of 100 and plug in and solve,
Okay.
right?
Okay, 3 by 5.
Okay. So after solving, I think you will get some answer 7.
So here the logic is to convert it into minutes.
Yeah, convert it into seconds because
Seconds.
one unit is in minutes and other is in seconds.
Okay.
Keep that in mind, right? Is it clear?
Yes.
Yes.
Yes, sir.
Okay. What about question number 13?
Did it.
So
Straightforward.
actually, I have tried,
Yeah.
but actually, I got a wrong answer. Actually, yes.
Okay, how did you try this one?
Just uh, firstly, put the value of y in the terms of the 0.85 into 0.5 and in the 0 and the with respect to all value, and
Okay.
then just I find the y square, and then I proceed as well as regular formula, and then I got the wrong answer. I think it's maybe
Calculation error.
calculation
Yeah,
wrong.
calculation error. Yeah,
I
approach is
don't
the
know.
same. Right? Okay, so yeah, there are two ways basically. One, he mentioned that instead convert all x's in terms of y. So your minus 0.5 would be 0.85 times minus 0.5. 0 would be 0 times 0.85. 1 would be 1 times 0.85, right? And so on. Another way to approach this is find the standard deviation of x, right? Find the standard deviation of x and then recall the property of variance, right? Variance of 0.85 times,
0.85.
that would be 0.85
0.5
times
square.
times variance of x, and then you can convert it into standard deviation by taking
Sir,
square.
what you said just now.
Okay, I will just give you a brief idea on it. Okay, great. Okay, so you are given a table, right?
Yes.
You're given a PMF table. You are given some values of x and its respective probability,
Yes.
right?
Yes.
So there are two ways. First way is I will write out some values 0, 1.
Convert all the values with y, and then we have to
convert it
calculate.
into a y. Y is your nothing but 0.85 times x, right?
Yes.
So your first term would be minus 0.5 into 0.85, right? This one
Yes,
would be
yes.
0.
I
This would
took
be
this
1.
approach only to calculate the standard. What was the other approach that you
Then
said?
find out standard deviation of y, right? Another way is find out the standard deviation of x. Okay.
Okay.
Then if you know standard deviation, you know variance of x also, right?
Yes, yes.
So you need to find variance of 0.85 times x, right?
Yes.
So which is nothing
So
but
whatever the
0.85.
variance value is there, just multiply it with square of 0.85.
So standard deviation of y would be nothing but square root of this.
Yeah, okay. Means this is I
Easier way.
forgot this one. To use this one. This is much easier.
Yeah. So that's, I think, calculation wise, it would be very easy.
Yeah, it will
Time
be
saving.
very easy.
Okay.
Excuse me, sir.
Yeah.
I want to ask you, in the previous method, will the probability also remain same, or
Yeah,
after
probability will always remain the
multiplying?
same. Probability will remain the same, right?
Okay.
Because the chances of getting value of 0.85 for y is same as chances of getting value of 1 for x, right? So it would be the same probability. Okay. Okay, moving further, question number 14.
So this, can you please explain, sir?
Okay, how did you approach this one?
Actually, I marked the first as the answer. It is probability. It is x less than or equal to 40. So I did that, and probability of A and probability of B I equated, because probability there is A and B are independently playing the games. So I found the probability of A winning in A will be playing for less than 40 minutes. Either of the one, since either of the one are playing the game, I put P of A is equal to P of B and multiplied them. No, I put P of A complement into P of B. So I got the first option as correct.
Okay. Okay, let me just write it down.
The same as binomial. Second thing is binomial function with n equal to 2 and p equal to 1 by 2, sir.
Yeah. Okay. Yeah. So you're firstly, you know that your random
Lambda is
variable X follows exponential, right?
Exponential, yeah.
And you know mean is 120,
1
right?
by lambda, yeah.
1 by 20.
1 by 20.
So your parameter over here is 1 over 20, right? Okay. So now you need to. Okay. What are the chances that any player would finish it in less than 40 minutes, right?
Yeah.
S less than 40 is same as your CDF of exponential at 40.
Yes.
Right?
Yeah. There's 1 minus e power minus 40 lambda.
Lambda
1 by 20.
Yes, right. So it will be 1 minus e raised to the power minus 2, right?
Yeah.
Okay. So now
This is one of them playing less than 40 minutes, right?
yeah. So this is the probability that any player would play less than 40 minutes, right?
Yeah.
Now what happens is now you have two players.
Correct.
Right. So your case one, you have two cases, right? Case one is that player one plays less than 40, right?
Yes.
And player two plays more than 40, right?
Yes.
Because we need exactly one of them is playing less than 40 minutes, right?
Yes.
Case two is
Player
exactly the opposite.
Player
right?
one opposite. Yeah.
And player two being less than 40, right?
40. Yeah.
So okay. So for case one, what are the probabilities? Both the players are playing independently, right? So
yes.
Player one intersection player two would be nothing but product of their individual probabilities, right?
Yes.
So what is the probability of player one playing less than 40 minutes?
1 minus e power minus 2.
1 minus e power minus 2. And player two playing greater than 40, it would be
1 minus e power minus 2.
It would be nothing but e power minus 2 only, right?
Yes.
Similarly, for the second case, it would be minus 2.
Yeah, the same.
And you need to add up, right?
Add up. Okay, sir. Thank you.
Yeah. Okay. Is it clear or any doubt in this?
Yes, sir. Thank you, sir.
Sir, can you also touch? There were a couple of questions like this in the 12th week assignment. That 5 people come together at the same time, 2 people got served before 7 minutes, like that. So, if we
that's also you have to put the same
approach here.
Same approach.
So in this question of 2 players, can you put 5 players and just explain one, sir? 5 players, out of which 2 players less than 40.
Okay, 5 player out of which exactly 2 are less than 40, right?
Yeah.
Mm.
I am able to solve whenever there is one player. Whenever it is 2 or more, I am getting confused, sir. So, sorry.
Sir, if it is exactly 2, then it's not a problem. We can simply put binomial and do, right?
Yeah, we will. Okay, let me just plug
The
in
calculations won't be much.
Okay, so if you see now, let's consider each player as a each individual player is a Bernoulli trial. Okay, with your success being that he plays less than 40 minutes, and failure being that it is greater than 40, right? And your probability of success would be same for each of these 5 trials, right?
Yes. Okay. That is 1 minus e power minus 2.
You have 5 independent Bernoulli trials, right? Because each player is playing time of each player is independent of each other, right?
Yeah.
So 5 independent Bernoulli trials with fixed probability of success, it is nothing but binomial, right?
Okay.
Binomial with n equals 5 and p equals
1 minus e power minus 2.
Minus 2, right? And now we need exactly 2 of these 5 are playing less than 40 minutes, right? So it would be nothing but 5c2, then probability of success raised to the power 2.
To the power 2. Okay, sir. Now I understood. Okay, sir. Thank you so much.
Okay. Moving further, question number 50.
Sir, I have this
Hypergeometric.
Yeah, hypergeometric.
So m is for rotten. So m equal to 12. Capital N is 72.
Yeah.
Small n is 2. Small n is 6. That's
6.
what.
Yeah.
So n into m by n.
Okay. Okay. Moving further, yeah. Next question. Last question, I think this is, yeah. Were you able to do this?
Yes, sir.
Anyone any doubt in this?
No, sir, I was not able to do this. I don't know even how to approach it.
Okay, but have you completed the Poisson distribution lectures?
No, sir, actually, I haven't watched this.
Okay, just
Poisson
go through
distribution,
that
hypergeometric.
first and then try to do it. Okay, I will leave it for you to
But
try.
hypergeometric, I have completed.
Okay,
Sir,
go through
can
the
we
lectures and
do
try to do it.
next mock test? I have a question in that.
Yeah, next mock test. Okay, some specific
Sir, I have
question you
just
can
a small
target.
question. In this mock test, I was able to do 8 questions out of 16, just half. So will that be enough?
I think if it's all correct, I think that would be enough.
Yeah, it's all correct.
Pass,
All 8
think,
are correct.
right? Depending on weightage of those 8 questions, I think.
Sir, how do you rate difficulty of this mock?
These mocks are, I think it's all the collection of good questions of previous end-term exam. So you won't be having
Sir,
all
how will
such
the end-term
questions.
exam be easier than this mock, or it will be more
Yeah, it
tough?
would be easier than this for sure.
Okay, thank you.
The solution for this has been posted.
Solution, it will be posted after the session.
Okay, thank you.
Okay.
Sir, can you scroll down? I'll tell you which question then.
Yeah.
So for this practice session also, for this also the solution will be there, no?
Sir, slow.
Yeah,
slow
solution
down.
will be listed. Yeah.
And one more thing, sir, after all the questions are finished, can I ask one doubt from a previous term question? After
Yeah,
everyone is finished. Okay.
Yeah, you can.
So not this. Scroll down, please. Yes, sir. This one. This one, sir, please.
Question number 10 now.
Yes, sir.
Okay. So how did you approach it?
Sir, I have taken out like the first is pass, and then like they have asked like if the student get pass marks exactly 4 weeks out of 5 graded, that means the conditions will be for this like 4 P's and 1 F. So that in that case, I'll get only the first should be P, and then pass, fail.
Okay.
Pass.
Student pass exactly 4 out of 5, right?
Yes, sir.
And we know that he passes the first test, right?
Yes, sir.
Okay. Let's try to make out some cases for that. Okay. Yes. Okay. So we know that first one is definitely pass, right? So I think there would be not more than these cases, yeah. And then it is possible that he fails in the second and pass in the remaining 3, right?
Yes, sir. There should be 4 pass and 1 fail.
Yeah. So I think these are the only possibilities, right? Pass, fail, right? These are the 4 cases, right?
Yes, sir.
Okay. Now we need to find out the probability for each of these cases, right? So what are the probability for these cases? So for that, okay, so if a student pass in the previous week, then there are 80% chance that student will pass in the next, right? And if he fails, then there is 40% chance, right? So we know that in the first, it will definitely, he is gonna pass definitely, right? So after passing, the chances of P is 80%, right?
4 by 5.
And after failing, the chances of passing is 40% only. So here he has passed in the first, then chances of failing in the second would be 1 minus 80.
0.2.
Yeah, 0.2, right?
Yeah.
After failing, the chances of passing is
40%. 2 by
40%.
Yeah.
After passing, now again, chances of passing would be
80%.
Then again, it would be 0.8, right?
Yes, sir.
Now for the second case, we know that the first is already passed. For the second,
Yes.
chances of
0.8.
passing would be, then failing,
0.2.
then again passing,
0.4.
then
and
again
then 0.8.
I will just square it this, right?
Yes.
Then here again it would be
0.8, 0.8, 0.2 and 0.4.
2 and 0.4, right?
Yes, sir.
For the last one,
0.8 cube, 0.2.
0.2, right?
Yes.
So this is the probability of passing exactly 4, right?
Yes.
Okay, and you need to find out the probability that student get pass mark in exactly 4 weeks out of 5. We know that, okay, it is given that. Then what is the probability that student passed in the 4th week, right?
Okay, 4th week only.
So let's say
Passed
this
in
is
the
your
4th week.
event A, let's say, okay? And event B is that he passed the 4th week, right?
So the first 2 cases and the last one.
Past 4th week. Yeah. This would be the consideration. This would be
This
the
also
consideration.
and the last one.
Now you can find out, right? So your A intersection B
So
would
this
be
much I have taken out. I don't have problem with this part. But my answer is not okay.
You need to find this, right?
Yes. Okay, B by A. Past 4th week. Yes. So B intersection A by B A.
A, right?
Okay.
So your A intersection B would be these 3 cases, right?
Okay.
It would be nothing but 2 times 0.8 squared. Okay, I will just simply add
Sir,
it
can
up
you
in
explain this part, A intersection B in this?
Okay,
What
so
is common in that?
A intersection B, the common are the highlighted ones, right? The 3
Yes.
highlighted boxes. These 3 would be the common cases only, right? Where he
Yes,
is
sir.
passing exactly 4 of 5 and also passing the 4th week.
Yes.
Right. So what is the probability of A intersection B? We need to add these 3 cases, right?
Okay. And
So
then divided by whole. Well, I mean
by the
divided by all
probability
the
of
P. Okay.
Yeah. So A intersection B, if I add, it would be, I can take 0.2 common, right? These 3.
Okay.
0.2 common and 0.8 squared also we can take common, right?
Okay.
So for the first one, we left with 0.4. Then again 0.4. And then we have 0.8 extra here, right? So that would be my intersection B, right?
Okay.
Similarly, in the denominator, I can again take these 2 terms as common, right? Then in the first one, again, I have 0.4 left out. And second one, again, 0.4 left out. In third one, also again, 0.4 left out.
Okay.
And last one, 0.8, right?
Yeah.
This is cancelled out, right?
Cancelled. Yeah.
So it would be 1.6 divided by 2, right? Which is 4 by 5.
Okay, sir.
Okay.
Thank you, sir. I got it. Yes.
Can I ask a
Excuse me,
question, sir?
Yeah.
Sir, actually, I have a doubt with the related to with 12 activity questions 12.3.
Okay, I will
The
come to it.
last
Before that, any other doubt in this mock, anyone?
So in previous mock, last question, like you told, we can
Sir,
In the previous
16
mock,
number question.
yeah.
With Poisson distributions, I'm not getting actually.
Okay, how did you solve this?
Sir, I have just taken that x less than or equal to 4 penalties has to be. So for equal to 5, so 1 minus I have taken when 5 penalties have been taken on that particular day.
1 less than 4 plus 5, right? Not only 5.
Only
Because x less than 4 you need to find, right?
Yes, sir. But lambda is given, sir, here is a 5 per day. So we have to convert lambda according to the penalties, right, sir?
Have you gone through the lecture videos?
Yeah, yes, sir.
Okay, so what are the possible values your Poisson random variable can take?
Here, sir, actually 4 are there, sir. Maximum 0, 1, 2, 3, 4.
Okay, so you are saying a Poisson random variable can take 4 values in this case only. 5 values, 0, 1,
So
2, 3,
5
4.
value, yeah.
It cannot take values beyond that.
No, it can take, sir. It can take.
Yeah.
According to question, Poisson random variable lambda, yeah, it can
Okay,
take.
it is less than 4, right?
Mm-hmm.
Less than 4 means 0, 1, 2, and 3 only, not 4.
Less than 4, okay.
Okay, so you need to add only those 4 values, not those 5 values. right?
So we have to simply take the lambda is equal to 5, sir, for the all cases. X will be keep on changing.
X, yeah, 0,
But
1,
in
2, and
some
3.
questions, when I've solved, sir, we have to, according to the lambda also, we have to change, like serving the customers 7 minutes, 3 minutes, 4 minutes customers. So we parallelly we used to change the lambda also.
No, lambda is it's your parameter for the distribution, right? It is fixed for a given question. At least for stats and coursework, it would remain fixed. We won't be having multiple scenarios, multiple random variables. You will see multiple random variables in stats 2, but not in stats 1 for now.
Hello, sir.
So here, sir, the answer would be like e to the power minus 5, 5 to the power 0 upon 0 factorial, kind of till 3.
Yeah.
Okay.
Hello, sir.
Yeah.
Excuse me, sir. In this question number 16, the value of x would be equal to less than 4, no? Is it
Less
right?
than 4 only. Less than 4 penalties, right? Less than 4.
So have to take the value 0, 1, 2, 3 only.
Yeah. That's what less than 4 is, right?
Okay. Thank you.
So can I ask a question, sir?
Yeah.
So I have to read the question. So can I?
Yeah, sure.
So there is a box which contains 3 white balls and 5 black balls.
Okay, let me just write it down side by side. Yeah.
There's a box, white balls and 5 black balls.
3 white balls and 5 black balls. Okay.
Yes, sir. We are transferring 4 black balls to an empty box, let's say B.
4 balls. Okay. Any 4 balls, right?
Yes. Now a ball is drawn from the box B at random and it is found to be white.
Okay.
What is the probability that out of the 4 balls transferred, 3 are white and 1 is black?
Okay. Okay. I think you have also posted on discourse or discussion forum somewhere, right?
Sir, I don't think so, sir. So I haven't posted it. I've kept it with me.
Okay. So how did you approach this one?
Sir, this conditional type of probability questions I'm not getting, sir. So if you explain this, the concepts might be clear, sir.
Okay. So it is saying that 4 balls are transferred, right? So
yes, sir.
What are the possible 4 balls it could be? It could be
3
4
white,
black
1 black.
balls, 0 white, right?
Yeah.
Yes, sir.
It could be 3 black, 1 white,
One
right?
Yes.
2 black, 2 white, and
3 black, 1 white.
1 black, 3 white, right?
Yes, sir.
We cannot have 4 whites, right?
Correct.
Yes.
Right. Okay. So what are the possible ways for all the 4 balls transferred are black?
5 choose 4. 5 choose 4.
5C4. 5C4.
Into 3 choose 0.
3 choose 0, right? And total number of ways were 8C4, right?
8C4.
Okay, sir. Yes.
Similarly, for the second scenario, it would be 5C3, 3C1, 8C4, right? Similarly, for other two, you can find out, right?
Yes, sir.
Okay. So these are your, different cases for different 4 balls being transferred, right?
Yes, sir.
Okay. So now in each of these scenario, what are the chances that the ball drawn is white?
First case is 0.
It is 0, right? For second case, it would be 1 over 4, right? The third case, it would be 2 over 4, and the fourth case, it would be
3 by 4.
3 by 4, right?
Yes, sir.
Okay. So now let us define the event. Your event A is that the white ball is drawn, right? And event B is that the transferred balls are 3 white and 1 black, right?
Yes, sir.
You need to find out probability of B given A, right?
Yes, sir.
So probability of given A is nothing but probability of B intersection A upon probability of A, right?
Yes, sir.
Okay, so your B intersection A, what would be B intersection A?
So last case, I think.
Okay, so B intersection A, I think, can we write it as this way?
A
given B into probability of B.
Right, sir.
So A given B means you have transferred these balls. Now, what are the chances that white ball is drawn, right? That's what A given B means.
Yes, sir.
So given you have transferred this, the chances of drawing a white ball is 1/4, right?
Yes, sir.
Times probability of B. Probability of B is chances of transferring 3 white and 1 black, which is this, right?
Right, sir.
By 8
No,
C4.
sir. No, sir. That is 3 black, 1 white. What you have highlighted is 3 black, 1 white. What we want
3
is
white, 1 black.
3 white,
Okay,
1
okay.
black.
Okay. Okay, you can.
It is 5C1 and 3C3.
Okay, let me just. Okay, you can just plug in the values, right?
Yeah. 5C1 into 3C3.
Into 3C3, right? Similarly, for the denominator, probability of A. Probability of A is white ball being drawn, right? So there are 4 chances. There are 4 cases where white ball could be drawn, right?
Yes,
That
sir.
you have ball transferred at this one and then white ball drawn. Ball transferred at this one, then white ball drawn. Ball transferred at this one, then white ball drawn. Similarly, this, right?
Yeah.
So that is nothing
Yes,
but
sir.
law of total probability coming into play, right?
Correct.
Is it clear?
Yes, sir. Yes.
Sir, I also have one question. Hello? Hello?
Yeah, please ask. Yeah.
Sir, will you be able to open the past paper 8th August 2021?
I won't be able to open it right now. Do you
Oh,
recall
because,
the question?
sir, I know, but the figure is there. So how I will tell you the figure? Like it's a graph.
Share the screen.
Which question you are referring to?
Sir, it's
Which topic question?
1 minute, sir. Sir, it's like the probability density function f of x of the plot, probability density, like the figure is given, and then they are asking what is the probability density function of the plot, probability density function which is given in the figure.
Okay, can you post it over discourse or discussion forum? I think we will answer it by tonight. We'll post it. Okay. Just
Sir,
share
okay.
your approach also in that. Like how did you approach this one? Okay.
So this one I couldn't, that's why.
Okay, just post it, right? We will look into it.
Yeah, okay. Thank you, sir.
Sir, can I ask the doubt that I asked for? These also are previous term questions. Should I read out the question? It's a pretty.
Read out. Yeah.
Okay, so in a particular game, the player needs to throw a dart onto a circular board whose radius is 5 units.
Okay.
The point allotted to the player are based on where the dart lands.
Okay.
Let R be the distance at which dart lands from the center of the board.
Okay.
Then the points allotted are 10 minus R, like square brackets R, where R means the integer part. Example, 5.5 means 5, 5.9 also means 5.
Okay.
Let X be defined as the sum of all the scores obtained after 5 dart throws.
Okay.
What is the expectation of X?
Okay.
I actually, the way I did was I actually calculated all the 1, 2, 3, 4, 5 like this.
Okay.
And then I calculated
0, 1, 2, 3, 4, 5, right?
Yeah, but I was thinking of 0, but how would 0 be there? Because
it's the distance from center, right? So if it's 0.1, it would be, or even if it's exactly on
no,
center, it would be
okay,
0.
okay. You're saying that, but I was considering the dart throws to be 1, first dart throw, second dart throw, like that.
No, R is the distance from the center, right?
Yes. Yeah.
So distance from the center, it could be anything, right? 0, 1, 2, 3, 4, 5.
Okay, so you are taking R as the like.
Yeah. So
I
your
was
possible
considering that
values are
yeah.
10, 9, 8, 7, and 6, right? And those 5 throws I will take individually: x1, x2, x3, x4, x5. Once I have the probability for x1, it would be same for x2, x3, and x4, x5, right? I can simply add them.
Your why is it 10, 9, 8, 7?
Why is it
10, 9, 8, 7, and 6?
Because your score would be 10 minus integer value of distance from center, right?
Yeah.
So if the distance from the center is 0.1, my score would be 10, right?
Oh, so yeah.
Similarly, it would be 9. The possible values are minimum it can go is 6, right?
Yeah, exactly. Yeah.
That's why. Okay.
So can I ask one?
Sir, a question from mock. Question number 4. Suppose we have 4 cards. Could you please open it?
Sir, I have few more doubts, but those are in the practice assignment. That will be released, right?
Sir, second mock test, sir, just above.
Second mock test. Okay, question number 4. Okay.
Could you please explain it, sir?
Okay, how did you approach this one?
Sir, my answer is 0.33, sir. Because
No,
we
what's
have
your
selected.
approach for that? Yeah.
I didn't understand, sir. That's
Okay, so I will just give you an idea. I think you can proceed.
Can I try to answer this, sir?
Yeah, sure, please do.
When one card which is opened has front face red, that means there will be only two cards in which the back side will one card will be red and the other card will be black. But because the other two cards will have black on one will have black on both the sides and the other one will have red and black. Out of 4, only 2 will be left, which will have the other side black, other side red.
Thank you.
Sir, can I ask one question?
Yeah.
The practice assignment 11, question number 8.
Practice
A
assignment.
minute, I'll just take out the page on which I have solved it.
Question number 8.
Okay.
So here I'm just again.
Sir, I hope the mock solutions, 2 of them will be released after the session. I have some doubts.
Yeah, it will be released after the session. Yeah.
Okay.
Yeah. So in this question, yeah, the mean is given, right?
Yeah, lambda is given, sir, 4.6.
Yeah. The 5 mobile phones. That this will not be enough to satisfy the demands of mobile phone that week. So it means you need to find that the 5 phones, more than 5 phones would be sold.
More than 5, right, sir?
X greater than 5.
Yeah.
So for that you can find out 1 minus x
Less than 5.
Less than equal to 5, right?
I did, sir, actually, but
okay. I think that might be calculation error, but yeah, the answer would be this way only.
So lambda would be always same 4.6 in entire calculation.
Yeah, 4.6, yeah.
But sir, I have done some questions where lambda is kept change. I think it keeps changing because of some data, I think.
No, it could be in multiple random variable cases. You will do that in stats too. For now, it would be the same because we are talking in terms of only one random variable.
Excuse me, sir.
Yeah.
Sir, excuse me, sir. I also have a doubt. I have posted in chat box.
Okay, one by one, please.
12, the week 12, the activity question 12.3, the last one question. The graph one, sir.
Okay, I think that was discussed in open session for week 12. You can refer to that session.
Sir, the 6th one question, sir, in this.
Yeah, this question was discussed in the open session. You can go and check it. Okay. It will also be available in the
posted a question in chat box, please.
Okay. A fair coin is tossed 3 times. If estimate the number of heads followed immediately by a tail. Okay, how did you approach this one?
Sir, actually, I have, according to me, there are 8 number of cases.
Yeah.
And it is asking about that it is followed by head.
Followed number of heads followed immediately by a tail. Yeah.
Tail, yes, sir. Sir, in that case, triple head and triple tail will be cancel out.
Yeah.
And the cases will be head, head, tail. Head, tail,
They won't
head.
be cancelled out. It will just be counted as 0.
0, yeah.
Yeah, okay.
Okay, yeah. Okay.
Head, tail, head, tail, head, tail. It will be 4 now. How it will be 5?
What would be 4?
The cases will be.
I did that sum. In that the two heads like head, tail come once, and in that we have to find the expectation. So we multiply it by 2 because it's of x2, right? So 3 by 8, which is like of x1, the expectation is 3 by 8, and of x is equals to 2, it is 2 by 8. So we multiply, 1 by 8. So we multiplied 1 by 8 into 2. So 3 plus 2 is equals to 5 by 8. If I'm
Okay.
Okay.
Got it.
Okay.
Thank you, sir.
So can I ask one?
Yeah, sure.
So can you tell the necessary and sufficient condition for a binomial distribution to become hypergeometric?
Sir, I saw
binomial
the
distribution is
content on
different from
the
hypergeometric,
whiteboard
right?
on the left side
So
about the supplementary contents, but it is not showing on my site, online degree.
it will be showing waiting.
That additional content course. This is not shown on my site.
It's
Additional
not shown.
lectures content.
Okay. Are you
Can I find
qualified
it?
student or a term student?
It is not uploaded on my site.
Same for me also, sir. Additional content, some of them I'm getting.
It is there.
No,
in
it's
week
not
12
there
after.
in my case.
It would be. If it's showing there, it is uploaded for all.
Well, it is showing only.
It's after graded assignment 12. Within the week 12 content, it is there. It's not after week 12.
Okay. I found it. Thank you.
Okay. So in binomial distribution, we have Bernoulli trials with probability of success being the same for each trial. Right? While in hypergeometric, it is not same because
So
we are doing
probabilities are changing, right, sir?
Yeah, probability is changing because we are doing it without replacement. So probabilities won't be.
So number of trial is fixed, right, in hypergeometric too?
Yeah.
And there was a statement in the slides. It said that the population must be dividable in 2 and only 2 independent subsets. So it is a necessary condition, right, sir?
Yeah.
Okay, sir. Got it.
Okay.
Sir, can you tell me the percentage of the weeks from week 9 to week 12? How much it could be?
70%.
70%, no?
Yeah.
So week 1 to 4, sir?
Week 1 to 4, no, but week 1 to 8, it would be 30.
So will we be getting any bonus marks at the end?
Bonus marks for?
So like submitting assignments, attempting
Yeah.
the
Not it's. I think for submitting practice assignment, you have 5 bonus marks.
Sir, I'm trying to submit the practice assignment, but some of them is still it is not blue marks. Sir. Every time when I go and submit, it's
Yeah, because it's a new set of question, but we have the track of how many times it's submitted.
And sir, most of the time I'm not able to complete the mock on time because I'm with some other work, sometime night duty. So will it
So
will affect
based
in my
on
marks? Yes, sir.
No, these are the bonus marks, right? So it won't
Yeah.
affect your total marks. It's bonus marks only.
The screen is not visible.
Yeah, I'm not sharing anything. Yeah. Okay. Anything else?
Is the session over? Actually, CT session is ongoing.
Yeah. I think we can wrap it up for today. Right?
Sure, sir. Thank you, sir.
Thank
okay,
you,
guys.
sir.
All the best for exam. Yeah. See you next time. Yeah.
Thank you, sir.
Thank you very much.
So will we see you in stats 2?
Hopefully, let's see.
Okay, sir. Thank you, sir.
Yeah.